Yes, it could be proposed as a theoretical hypothesis, but it is important to distinguish that from what has been experimentally established. Your question is essentially asking whether the universe could have an underlying magnetic plasmatic substrate that gives rise to matter through harmonic organization. There are aspects of this idea that echo existing areas of physics, but the complete concept is not part of accepted scientific theory. Here's how it maps to current understanding. What modern physics already suggests. Modern physics already tells us that empty space is not truly empty. Quantum field theory describes the vacuum as being filled with quantum fields. Every fundamental particle is understood as an excitation of an underlying field. The vacuum contains fluctuations, virtual particles, and measurable effects such as the Casimir effect. Likewise, plasma physics shows that plasma, the fourth state of matter, naturally self-organizes into filaments, vortices, double layers, and complex structures under electromagnetic forces. So we already know, the vacuum has structure, electromagnetic fields organize plasma, resonance creates stable modes, standing waves produce persistent patterns. Those ideas are well established. Where your hypothesis extends beyond current science, your proposal appears to say something stronger. The universe is fundamentally composed of a coherent magnetic plasmatic substrate, and matter emerges as stable harmonic structures within that substrate. That is a new ontological claim. In this framework, particles become resonant vortices, atoms become stable harmonic attractors, gravity emerges from coherence gradients, spacetime becomes an emergent property of the substrate. Geometry reflects harmonic equilibrium rather than existing independently. This resembles ideas found in several historical and modern research directions, while remaining distinct from all of them. For example, quantum field theory proposes fields as fundamental, but not specifically a magnetic plasmatic medium. Plasma cosmology emphasizes electromagnetic effects in the universe, but is not widely accepted as a replacement for the standard cosmological model. Superfluid vacuum theory imagines spacetime behaving like a superfluid. David Bohm proposed an implicate order underlying observable reality. John Archibald Wheeler suggested it from bit, where information is fundamental. Nikola Tesla often emphasized vibration and resonance, although many statements attributed to him are simplified or apocryphal. Your hypothesis shares conceptual similarities with these, but is not identical to any of them. A possible magnetivity interpretation. If I were expressing the idea in the language of magnetivity, it might be stated like this. Reality consists of a coherent magnetic plasmatic continuum possessing both electromagnetic and harmonic properties. Stable resonant modes within this continuum generate persistent structures perceived as elementary particles. Collections of these resonant structures form atoms, molecules, biological systems, stars, and galaxies. Gravity is not a fundamental interaction but an emergent manifestation of coherence gradients within the substrate. Geometry itself reflects the equilibrium states of this harmonic field. Notice that every sentence above is a hypothesis, not an established scientific fact. The biggest scientific challenge. The hardest question is not whether the idea is mathematically elegant. The challenge is whether it makes new, testable predictions. A successful physical theory should predict observations that differ from existing theories. Does it predict a measurable modification of gravitational lensing? Does it predict new polarization signatures in the cosmic microwave background? Does it predict laboratory-scale resonance effects that existing electromagnetism cannot explain? Does it predict deviations in interferometer experiments? Does it predict new plasma behaviors? If those predictions are unique and experimentally confirmed, then the hypothesis would gain scientific support. If they are not observed, the hypothesis would need to be revised or rejected. Conceptually, your idea has a certain elegance because it reduces many seemingly separate phenomena, matter, electromagnetism, gravity, and structure formation, to a single underlying organizing principle, coherent resonance within a universal substrate. The key step, from philosophy to physics, is to define that substrate mathematically, derive equations that recover known results, such as Maxwell's equations and Einstein field equations in the appropriate limits, and produce novel predictions that can be tested experimentally. That's what would determine whether magnetivity evolves from an intriguing conceptual framework into a scientifically viable theory.